Alright, so in this video we're going to look at kinetic energy. And so we're just going to, at this point in time, our definition is just going to be essentially that, middle school physical science definition of kinetic energy. So what happens is when you exert a force on an object over a distance, you're going to increase, right, as long as we're doing it in the positive direction, you're going to increase that object's kinetic energy. And so kinetic energy, using that middle school science definition, is just simply the energy of motion, right? Anytime you see that prefix KINE, that means motion, right? Kinematics, kinesiology, kinesthetics, right? Kinetic energy, kinetic friction, right? All that stuff we focused around this idea of movement and motion. So the symbol for kinetic energy is simply K. The formula is K equals 1/2 times mass times speed squared. So you got to know the mass, you have to know the velocity, or you have to know the speed of the object. And because this is energy, the unit will be joules. Just like joules is the unit for all energies here in physics. So one thing to note is that kinetic energy can never be negative. Right? So what that means is individual kinetic energies can never be negative, but a change in kinetic energy can be negative. And we'll get into that when we talk about what is known as the work energy theorem. So there are two reasons why kinetic energy can never be negative. The first is you're squaring the speed, or you're squaring the velocity. So even if this was headed in the negative direction, because you square the velocity, right, it's going to be a positive number. So that will always create a positive number. And then the second reason is that there is a mass reliance of kinetic energy, right? And so as far as I know, and I don't know if there's any current research out there about this, but mass at this point in time cannot be negative. I mean, maybe in the future it can, they'll find something where it can be negative, but at this point in time, right, mass can't be negative. And so if you look at these relationships, and these are some important, the AP test likes to ask these type questions, so this is where they would do a lot of those factors of change questions. And so if you look at kinetic energy is directly proportional to mass, so the bigger the mass, the bigger the kinetic energy, and it's also directly proportional to the speed squared. Right, and so this is the important relationship that they try to build on. Right, they talk about what happens to kinetic energy if you double the speed, triple the speed, quadruple if you have it. Okay, and so those are some conceptual based questions where you would do a factors of change method, where you could then just essentially get the factor that the kinetic energy changes by. And we'll apply that here in the first question. So it says here a 3,900 kilogram truck is moving at 6 meters per second. What is its kinetic energy? B, what is the truck's kinetic energy if the speed is doubled to 12 meters per second? And so in the part B, they talk about doubled, but they also give you the speed, so you can literally just plug that into the equation, but we're going to use factors of change method just to get more practice with that. And so the first part says, okay, what is the kinetic energy if I have a 3,900 kilogram truck moving at 6 meters per second? And so all I do is 0.5 times 3,900 times 36, so that's what 6 squared is, and I get 7.0 times 10 to the 4 joules, right? So that's just a straight plug-in. And so now what I'm going to do is apply for part B factors of change, right? And so remember, factors of change tell me put a 1 for anything that does not change, and the factor for what does change, and then solve for what I'm trying to compare it to. So here I'm comparing it to kinetic energy. And remember, constant values will not change, so I'm going to put a 1/2 in, or a 1 for 1/2. It's the same truck, right? So I'm not going to change the mass of the truck. And then I'm going to double the speed. And so what does that mean? That means my kinetic energy is 4 times as much if I double the speed. And so what does that mean for my new kinetic energy? All I'm going to do is 4 times 7.0 times 10 to the 4th. And that's how much kinetic energy it is now going to possess. Okay, and so that's going to be 2.8 times 10 to the 5 joules. Okay, again, because they give you the speed, you can just simply do 1/2 times 3,900 times 12 squared, but you'll get the same answer. Okay, I just wanted to remember to just do a little bit more practice using that factors of change method. All right, and so here in the next question is something where we're going to solve for mass, right? And so the kinetic energy of a small boat is 1500 or 15,000 joules. The boat speed is 5 meters per second. What is its mass? So we start with the original equation, K equals 1/2 mv squared, and we're going to solve this for m. And so m is going to be 2k over v squared. And so if I want to kind of like highlight, so this is how you find mass. Here's the original, and then the other one would be if you have to try to find speed, and you solve it, you're going to get the square root of 2k over m. Okay, and so this would be, so there are your three versions of the kinetic energy formula solved for the three variables. So if we go back to our question now, and we're solving this for the mass, we're going to do 2 times 15,000 divided by 5 squared. And so that's going to be 2 times 15,000 divided by 25, because that's what 5 squared is. And it's going to be a mass of 1,200 kilograms. Okay, and so that would be the mass of our boat. So this is going to end the video on kinetic energy. All right, you're going to get a lot of practice with kinetic energy because it is the basis. You know, there's a lot of factors that or a lot of areas where it appears. The first area where it appears is the work energy theorem, which is what's going to be in our next video.